Hello. In this tutorial, I would show you how to build your own in-place state machine for your game. It's a very quick solution that works really nicely. And for example, in this character movement thing I've got here, I have the state machine trigger based on different speeds the character reaches. So not only I'm printing constantly which state I am in, but I'm also triggering a color change when I get from walking to running and back. I return to normal color. So yeah, let me just show you around the actual state machine. It's rather simple, so I'll just explain as I go. So in here, this part is really the entire code for the character movement, including these two top variables, right? This stuff just takes care of moving the character and updating the velocity and position. So that's stuff that's irrelevant to the state machine itself. The state machine itself, in this case, I'm using an enum, but you could also just use plain strings. So I have an enum here to define all the states the machine can be in, and then I have a variable for the actual state of this current character, right? And then we have what's called the beef of the state machine, and that's the state rules. So you can imagine the state machine in here similar to what an Godot's animation tree state machine is, where you have a bunch of states and then you'd have a condition to move from one state to another. And you can basically just define the conditions, and then you'll be in this state waiting for any of the conditions to switch away to turn true, basically. So that's how this animation tree, or sorry, how this state machine works. It works really nicely as well, and it's, as you can see, the code is very short just for like this setup. So you don't even need to have it on a separate node. And yeah, it also triggers events. It triggers signals. It emits signals when states are being switched from and to, and it's actually really simple to work with. So here I have a very basic example. So I've defined rules in the state rules dictionary for standing, walking, and running. So this basically a dictionary member defines another dictionary in it that will define both the switches away from, so if we're in the movement state standing, this defines all the switches to basically that can happen away from this state. And the way this works is I have a switches member, just a string, so I can easily call it or access it. And it contains another dictionary that takes the state we're switching to as a key, and it in the value it stores a lambda. And that lambda just needs to return true or false if we can switch, basically. And that's all there is to it, right? So in my switches, I've defined that I can switch to the movement walking if our velocity length is bigger than 50. And the state machine will just check for that condition every frame while we're in the standing state. You can also notice we have a callable here, and that's just a function reference for what do we call from the process when we're in this state. And if I control click this name, you can see I just have defined here a process for standing, a process for walking, and a process for running, and they just print out the state. So you can see all of those in action as I was going through the different speeds in the demo. Now you can also notice I have two switches function callbacks here defined, but you'll see where those link in later. So yeah, that's the rules. You can also notice I can have multiple switches. For example, for the walking, I can go back to standing, or I can go further away to running, and then from running I can switch back, and then there's based on the different speeds. I have here. Now, in order to actually have signals emitting from each state change, if you actually wanted to have signals for each of the states, you can't just generate them here. You can't just go like switch from signal and then do like signal like that, because you don't generate signals this way. The way to actually generate signals is further down here, where what I have basically is a generate state signals function, and it first initializes an index so we can distinctly find those signals after we create them, and then we loop through all these states in our state rules, right? So through all of these keys, and for each one of them we generate a signal, and that's how you do it. It's called an add user signal. We just give it a string. In this case, I stringified the index in here, and then I put it into a switch from member. So you can imagine after this is happening, there's a new member here called switched from. That's what this code does, and it will contain this signal reference. That's all it's going to be doing, right? So I add, and then this is how I actually get the signal. So I'm telling it that I need to find the signal on myself that has the same string as the one we just created, and that's it. Now we have a reference to that signal, and we can connect to it using this access address, and then also increment the index so we can get a new signal with a new address for the switched to. So that's the same. Now every state in our state rules would have a signal available to both emit and connect to, and you can see I'm already doing it over here. So in a ready function, we both make sure to call generate state signals, so actually to initialize all the signals and put them in where they belong. And afterwards, all I can do is in the state rules, I get the running state, and then I find the signal switch to of that running state. So this signal switch to will be emitted when I switch to the state running, right? And I connect switch from walking to running, which is another function I've made here. And all it does is changes my color of the character from normal to fully red, for example. And then I have another one for the switched from of the same state. So when running is switched from, and I'm assuming back to walking, I'm calling this, which just sets the modulate back to normal. And that's it. That's all needs to be done from ready. And then I also have, so outside of the movement code, I also need to handle the states on the process. Now that's something you'd see on every state machine. That's just what state machine does. It checks and updates the state every time. I mean, you can have other different types of state machines that are like delegate based, but this one, if you want to have an enemy that constantly needs to do something based on its state, this is very convenient. Now this isn't the perfect solution, but look at how quickly and simply I can make like a functioning state machine with delegates and process callables, and how easily I can just extend upon it. I can have a jumping state and just define all the switches from running, walking, and from jumping back to all of those very easily. But it's still down to how I implement the handle state, which is happening here. So I loop through all the switches. So notice, I'm not looping through all the states now. I actually know what state I am in, right? That's the current movement state, in which case it is set to standing at the start, right? I know which state I'm already in. I'm looping through all the switches that this state can perform. And now if this switches, and notice what I'm doing here. I'm getting the movement state. I'm getting the switch we're currently iterating through, in which case it's actually going to be another state variable, right? So if we're in standing, it's going to loop through walking. If we're in walking, it's going to loop through standing. It's going to loop through running, right? And then that key I'm putting back into the switches dictionary to get the callable. I'm getting this lambda now, right? So this switches, and I can just perform what's called, like I can just call it, right? Now, because I'm returning a Boolean value, I'm returning a condition, this switch will return me a true or false, which I can plug directly to an if statement like so. And if the switch is a valid condition, so I can actually perform a switch, I am performing the switch. So I'm first emitting the switched from on our previous state. So I'm getting the switch from signal and I emit it. Then I switch the states, and then I perform the switch to on the new state. Now it has already switched, so I'm performing a switch to emission. And then it's important to break, because if you don't break, this might lead to multiple conditions, multiple switches triggering at the same time, and like within the same loop, and that's not good at all. So yeah, important to break. And after we've performed any switch that might be happening, we can actually call the callable related to the current state we're in. And we're just calling, passing in delta, and that's how we have all of that and all of that. And now, as you can see, let's go through this again. I can just go around, and you can see the color changing and the printing constantly based on what state we're in. So yeah, hopefully you'll find this useful.